Okay, we're going to continue 4.1, and here we have three equations which we want to graph. We want to find their domain and ranges, and we want to find any horizontal asymptotes. So let's start with 3 to the x, and we'll try to do all of these, or at least a couple of these, on the same graph. Let's label some points here. Okay, and let's do for 1 here just a couple of points to get us going. So -2, -1, 0, 1, and 2. And if we do these, we'll get 1/9, 1/3, 1, 3, and 9. And so what we get is we have the following. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 here. Let's label these points. So -2, we're at a 9th. -1, we're at a 3rd. 0, we're at 1. 1, we're at 3. 2, we're way up here at 9. So this one grows even faster than the 2 to the x functions. And so we end up with this kind of graph. Okay, so this is the graph for 1. Now again, 3 to the minus x. Well, let's first do the domain and range here for 1. So we have the graph. The domain here is all real numbers. So for any of these exponential functions, the domain is always all real numbers. The range is the only part that's different. In this case, it's 0 to infinity. So we've completed, when we have a horizontal asymptote right here at the x-axis, just like with 2 to the x. So for the horizontal asymptote here, it's the line y equals 0. Now, for the other graph, notice that it's exactly just the flip. So this again is 1/3 to the x power. So it's just replacing x with minus x. X gets replaced with minus x. So we simply flip the graph across the y-axis. And so this is the graph of 2 here, 3 to the minus x. And the domain and range are the same actually. So its domain is also -infinity to +infinity. Its range is also 0 to infinity. And it also has the same horizontal asymptote, y equals 0. Everything is the same except the graph flips across the y-axis. Now the one that changes things is number 3 here. So let's do 3 a little bit separately because it's a bit different. So for 3, we have y equals 3 to the x minus 1 plus 1. So how do we get there from 3 to the x? Well, we have 3 to the x that if we replace x with x minus 1, so this is what we have to do to get from 3 to the x to 3 to the x minus 1, and that's a shift to the right by 1 unit. And then we finally get the final graph, which is adding 1, and what that does, the adding 1 part is a shift up by 1 unit. So you can think of these in terms of shifts. Of course, you can just directly plug in points. We'll try to do a little bit of both, so you see both methodologies. So let's just make a few points here, x, y, and see what happens. So let's do -1, 0, 1, and 2. So if we have -1, we have 3 to the -1, or So 3 to the minus 2 plus 1, this is 1 and a ninth. At 0, we have a third plus 1, which is 4 thirds. If we plug in 1, we get 3 to the 0, which is 1 plus 1, which is 2. And at 2, we get 3 plus 1, which is 4. So let's plot these points, because these points are going to be useful in doing the graph. And we'll see that it ends up being exactly the shift that we talked about. So at negative 1, we're at 1 and a 9. So here's 1, here's 2. So we're a little bit above 1. At 0, we're at 4 thirds, 1 and a third, so it's a little bit higher. Let's plot these points in a different color here. 1 and a third is a little bit higher. At 1 here, we're at 2. And at 2, we're at 4. So we've now jumped up 3 and 4 somewhere here. And here's 4. Now what happens, we can draw the graph, but where is this tapering towards? Where is the horizontal asymptote? Well, the original horizontal asymptote was, the horizontal asymptote here was y equals 0. All we do is bump that up by 1, because shifting it to the right doesn't change the asymptote. Shifting it up does change the asymptote. So from y equals 0, we now have a horizontal asymptote of y equals 1. And so this graph continues to get closer and closer to the line y equals 1, which is our horizontal asymptote. Okay, so we've gotten the graph now, and notice that indeed in terms of points, notice that if I wanted to think of it as a shift, let's start with one point here. So if I had the original point on the graph right here, which was 0, 1, and I shifted that to the right by 1, right, because we're shifting it to the right by 1 and then up by 1. So 0, 1, if I shifted it to the right, it would become 1, 1. And then if I shifted it up, it would become 1, 2. And that's exactly this point right here, 1, 2. So literally you could kind of look at points and say, okay, let me fix one point in the original graph, move that to the right by 1 and then up by 1, and that'll give me the new point in this new graph. So, and it's good to have maybe one point as a reference, especially if you're only going to use the shifting method, then have one point as a reference when you're doing the shifting. And then shift the asymptote. Okay, so the last part of this now is the domain and the range. So here is our function, 3 to the x minus 1 plus 1. What is the domain and what is the range? Well, I've already told you any exponential function, the domain is always going to be negative infinity to positive infinity. The only question is, what is the range? Well, you can see here, the range got shifted up by 1, so the range changes to 1 to infinity, and again, not including the number 1. Okay, so this is the end of 4.1. In the book, there's an additional topic which I'm not going to be covering, but this is the end of 4.1 that we're going to be talking about. In the next video, we'll start 4.2.